All right, magnetic compass. What are my errors associated with magnetic compass?
Coasting.
Here, go over the edge.
Thanks, sir. I love Tuesdays. All right.
Variation.
Variation. So, first question, variation. Variation. What is it? Does it affect me as an IFR pilot?
Not as much, yes. Because your charts are already accounting for it,
K-charts are magnetic or true?
but magnetic.
Magnetic. VORs are
Magnetic.
magnetic. GPS is
I don't know.
magnetic. Runways are.
Magnetic.
So do I even use true north in IFR flying?
No.
I really don't. So variation doesn't really come into play. All of our charts, our procedures, everything's already written into magnetic. The only reason we use true north in like private pilot is because you're planning point to point on a map. You're not planning point to point on a waypoint or something like that.
For wind correction angles and stuff, you'd still need the true, or at least the variation differences west and east.
We'll
right?
get into that when we get into flight planning. Would you ever do an IFR flight plan by hand?
No.
No, why?
Too long.
Harder.
We're lazy.
Because that is a situation you cannot afford a mistake in. You're in the clouds, okay? In theory, this is the way I look at it. IFR flying, you're already in the clouds. Can you see the ground? Guess what? You're already in an emergency. Anything else goes wrong, and you're really in trouble. So at that point, you do not want to be leaving it up to. I don't know about you guys. If I tried to do 3 flight plans in a row, I guarantee you I'd mess up at least one of them. At least. Because there's like one calculation you mess up at the top, and it messes up the rest of the flight plan. So IFR flight planning, when we get into that, we're going to do that all computer. Okay? It's going to give us, we have to verify that the computer put in the right points. But when we get into that, we're going to trust that more than ourselves. Okay. What else?
Deviation.
Deviation. And what is deviation?
It's the deviation of the compass.
What causes deviation?
Magnetic fields.
What magnetic fields?
Aircraft. Local magnetic field in the aircraft.
Specifically, what's causing
Radios.
Wires.
Radios.
Electric
Anything
flow
metal.
wires.
Anything.
the electromagnetic flow. Okay? So, anybody ever looked at your compass, especially like in the katanas, when you turn on your master switch, what happens? How much? How much? A little bit.
About 30 degrees.
5 to 10. Okay? Watch your compass next time your student turns on that master switch. That compass moves about 5 to 10 degrees. Now the question is, was the compass reading correctly when the airplane was off or on?
Off. On.
Off.
Off. Oh, because they change it. They have to
That's
turn
how
it
you
on.
gotta do it.
Ah, okay. So, it is reading correctly when it's on. What does your compass card say in a katana?
It says radio's on.
For this heading.
It says radios and
And
lights.
lights.
Radios and lights are on. So here's how it works. You turn on your radios and lights. Tyson?
Yep.
You turn on your radios and lights, and that creates an electromagnetic disturbance. So the mechanics take it out. If you ever see them out there, you'll know what they're doing now. It looks like one guy's standing out there pointing a gun at the airplane. And you're like, what the heck are they doing? He's got a true compass. So the guy in the airplane lines up the airplane, and they say, okay, you're on north right now. The mechanic then uses these 2 little screws down here that are attached to little magnetic rods underneath to then adjust for that electromagnetic disturbance. In the katanas, what's the most that little card says?
5?
5 at the most, I think, in one of them. Usually 2 to 3. Okay? But when you turn that on, you'll notice it swings 5 to 10 degrees. So that deviation card in your airplane is simply telling you what the mechanics were unable to correct. That's it. The true deviation of your compass is unknown. Does that make sense? Okay, so deviation is only what it's what the mechanics have fixed. So, if I'm flying using a compass, how accurate can you fly a compass? Within how many degrees?
2 to 10.
5. It's got 5 degree increments. I can hold it within 5. Can you hold it within 2 or 3? I mean, you're better than I am if you can. So, does deviation really affect us?
No.
No. It's been corrected, and if we lost our electrics anyway, guess what? We don't even know the deviation. So it doesn't help us out anyway. So literally the only thing we should be using that deviation for is, in a katana, setting my heading indicator. When I look at my deviation card, +2, I should set that +2 on my heading indicator. Other than that, that deviation doesn't really have it. Now, this is a misnomer that we often do, and your students will actually fly the wrong number. On their flight plan, they put in the deviation, right? That's what we teach them to do. Are they using a compass to fly or a heading indicator?
Heading.
So once they've set that heading indicator correctly, is there any deviation? Watch your students, I bet you they're flying the magnetic compass heading when they fly their flight plans. They should be flying the heading before that correction. That heading should only be used if you were flying with a compass only, which would be if your heading indicator failed. Which I doubt any private pilots really know how to do compass turns anyway. Does that make any sense? Okay, so on that flight plan, really, that deviation should not even really be included unless you're planning on them flying with their compass. So make sure they understand that. Do they really get what deviation is? So corrected for, what's my last magnetic compass area then?
Magnetic
Dip, is that like 7-layer dip?
Close.
That was good.
Minus the sour cream. What is magnetic dip?
Compass is trying to point directly towards the North Pole, which is not at the horizon, it's through the horizon, it's below it.
It's below the horizon, so points. So do I have to, this is where people get confused with that kind of explanation, because that's how we say it, is then somebody says, I say, okay, well if I'm on the ground, will I get magnetic dip? And they say, no, you gotta be in the air, because it's gotta point down. Because they relate being up and down to altitude. Okay, if that makes any sense. So here's an alternate, I don't care. If you guys need to come up with more ways to explain it. Here's an alternate way to think about it. If I am at the equator, do I have magnetic dip?
No.
I don't. So, here's a way to look at it. If I'm at the equator, think of it like a teeter-totter. My compass is balanced. I've got, every compass has a north and a south pole on it, right? Because every magnet has a north and a south. So all it does is that compass is simply aligning itself with those magnetic fields. If you look on the bottom of this, all it has is 2 rods. Okay? I can put that on my finger, and it will turn and align itself with the magnetic headings, okay? Excuse me. So at the equator, I got the North Pole pulling on it, I got the South Pole pulling on it. We got 2 people that live at the same size sitting on the teeter-totter. Well, now I move up here. Am I closer to which one? So now I'm closer to north, further away from south. So it's not necessarily that north got any stronger, south got weaker. I don't have an even balance anymore because I've now moved farther away from it. My compass starts to tilt a little bit. Now I get up here, I've got like almost no south pole anymore. I mean at this point, and it is. Technically it's down here inside the earth somewhere, whatever. If you explain it that way, that thing goes just straight down. Above what latitude is a compass unusable? 60 degrees. Above 60 degrees latitude, it's just trying to just point down because there's no south pole to balance that compass anymore. There's nothing to keep it level, and so just like a magnet, if you ever played with them as a kid, they just want to flip right up on end and connect to the other one. So, same thing, if I come down into the southern hemisphere, it's going to do exactly the opposite. It's going to dip into the south pole. They do sell north and south pole compasses, by the way. So, north and south hemisphere compasses. Okay? Questions on that?
So a compass is unusable above 60 degrees latitude, north or south.
So if you ever talk to somebody in Alaska, I met one guy and I said, so how do you fly up there if you can't use your compass? And he goes, oh, we have landmarks. I said, well, what do you do in low visibility? Well, we use closer landmarks. Okay. So, flying IFR by flying towards a mountain, whatever.